Okay, today we're going to pick up where we left off yesterday in section 2.1. We're going to start with reflections. Reflection across a y-axis. So whenever we're doing a reflection across a y-axis, it's going to be inside the parentheses, especially with quadratics, inside the parentheses of the x squared. Now the funny thing with this one is, if we take the square of any negative, it makes it positive again, so it's indistinguishable from the first one. Meaning, if it reflects across the y-axis, this side flips to this side, and it looks exactly the same. So the function f of x equals x squared is its own reflection across the y-axis. If we're going to reflect it across the x-axis, the output values change. That means that I'm putting a negative in front of the parentheses, which leaves it as a negative x squared. That's going to flip this downward. If the original is here, it flips it downwards across the x-axis. Horizontal stretch and compression by a factor of b, the input value changes. So if b is greater than 1, it's going to be 1 over the number. So if it says like if it says it's a horizontal stretch by a factor of 3, that's going to be 1 over 3. If it's a horizontal compression, that's going to be, if it says it's a compression by a factor of 1/3, you put 1 over 1/3, or you flip it. It's just going to be 3 over 1. So the only time that it's going to be a horizontal compression is if the number is between 0 and 1, or a fraction or decimal smaller than 1. A vertical stretch and compression is multiplied by the x squared on the outside. So it doesn't get squared like when we're looking at horizontal. This number is also getting squared because it's in the parentheses. A vertical is outside of it. It does not get squared. So I take my function x squared and I multiply it by a number. If that number is bigger than 1, then it's going to be a vertical stretch. If it's less than 1, it's a vertical compression. So it compresses down towards the x-axis. So if this number here, we don't flip it, we don't put it in a fraction form or anything, it's unlike the horizontals. If that number is a number bigger than 1, it stretches away from the x-axis. And if it's smaller than 1, or a decimal or a fraction, it's going to compress towards the x-axis. Use the graph of f of x equals x squared as a guide. Describe the transformations, then graph each function. So before I graph each function, I'm going to need to describe my transformations. So x squared is my original. I see I have a negative out in front. That tells me it's going to reflect across the x-axis. Additionally, this is a 1/4. It's not in parentheses, so it means it's a vertical. Since this is a fraction, it's going to be a vertical compression. And that's going to be a factor of 4, or of 1/4. The fact that it's 1/4 tells us that it's a compression, so we could go with a factor of 4. I wouldn't mark it wrong if you had a factor of 1/4. Okay, so if I'm doing a rough graph here, so now whenever we graph this, I took a big long break there. I got a phone call. When we graph this, our original graph, we've gone over 1, 2, 3, 4. I like to just mark it out a little bit. So 0, 0 would be there. then it would also be at -1 and 1, then at 2, 4, -2, 4, into 2, 4, and that would form my U. This new one, because we're talking about a vertical compression, it's now flipping over the x-axis, as we said. Vertical compression by 4 means that this point where it would be at 1 is now only going to be at 1/4. Same thing here. This will only be at 1/4. This one, which was up at 4, will now be at 1. And this one that was up at 4, I'm just doing 1/4 times the 4 that it would normally been, would now be at 1. And so when we graph this, it's still going to be a U, but it's going to be upside down because of the negative. And it's going to seem like it is completely squashed down. I realize that that's not the most precise graph, so let's graph the original x squared. And let's do -1/4 x squared. And you can see the original was up here, and it is, in fact, more narrow than this one, which is just pushed down towards the x-axis, giving it a vertical compression. Using the graph f of x equals x squared as a guide, describe the transformations and then graph each function. So this one, if I'm looking at it, because it's inside the parentheses, it tells me it's going to be horizontal. Because it's multiplied, it tells me it's either going to be a stretch or a compression. The question is, what will this be? Well, if it's a stretch, it would be 1 over the number. In this case, it is not that, which tells us this is going to be a horizontal compression by a factor of 3. If I graph that, 3 x squared. If I look at this original graph being in red, let's get rid of the blue one just so there's no confusion. Original graph in red, the transform graph in green, you can tell it's been compressed horizontally, pushed in from both sides towards the y-axis. I'd like to give you an opportunity to get bonus. So, if you're viewing this, the word of the day is vertex. The word of the day is vertex, which means you will get 5 bonus points if you email me the word vertex. If you put it on Google Classroom, I'll delete it. You get no points. You have to email it to me. Okay, if a parabola opens upward, it has a lowest point. If a parabola opens downward, it has a highest point. This lowest or highest point is the vertex of the parabola. The parent function f of x equals x squared has its vertex at the origin, which is at 0, 0. You can identify the vertex of other quadratic functions by analyzing the function in vertex form. The vertex form of a quadratic function is f of x equals a, or just some number, times x minus h squared plus k. This is where a, h, and k are constants. So those are all numbers that don't change. When we look at the vertex form of a quadratic, we have f of x. Don't even worry about that. A indicates either a reflection across the x-axis and or a vertical stretch or compression. The H indicates a horizontal translation, whether it be moving right or left. And K indicates a vertical translation, moving up or down. We're going to get into vertex form more tomorrow. You have an assignment that's been posted. Complete that, and we will move forward. Tomorrow we move forward with the vertex form and really get into graphing these equations in a little bit of an easier fashion if you understand how to do it.